In this lesson, we're going to be checking solutions of systems of linear inequalities, graphing systems of linear inequalities, writing systems of linear inequalities, and using systems of linear inequalities to solve real-life problems. A system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown below. Y is less than x plus 2, y is greater than or equal to 2x minus 1. A solution of a system of a linear equality in two variables is an ordered pair that is a solution of each inequality in the system. So for the first example, we need to tell whether each ordered pair is a solution of the system of linear inequalities. So my first ordered pair is 3, 5. So I'm going to plug this into both of these inequalities. And if they're both true, then it is a solution. If one or more of them is not true, then it's not a solution. So first I have 5 is less than 2 times 3. 5 is less than 6. That is true. So the first one works. And then the second one, I would have 5 is greater than or equal to, and then my x value here is going to be 3 again. So it's going to be 3 plus 1. Okay, so this simplifies to 5 is greater than or equal to 4. And that works. That works. So this is a solution for part A. For part B, I'm going to plug these values in for x and y again. So for the first one, I have y is less than 2x. So that's going to be 0 is less than 2 times negative 2. This is 0 is less than negative 4. Well, this is not true. 0 is larger than negative 4. So right away, I can already tell that this is not going to be a solution. You could plug negative 2, 0 into the bottom equation first, and that would work. But because the first equation doesn't work, you don't even have to. Anyway, we figured out that this is not a solution, so now we're done. The graph of a system of linear inequalities is the graph of all the solutions of the system. So to graph a system of linear equalities, step 1 is graph each inequality in the same coordinate plane. Step 2 is find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. Okay? So right here, the shaded region that both of these are on, the pink part and the blue part, this is the solution set. So just this little chunk right here. And it'll make more sense once we actually do our graphing in the next example. So for this example, we want to graph the system of linear inequalities. We have y is less than or equal to 3, and then I have y is greater than x plus 2. Okay? So for the first one, the slope is 0 because there's no x term, and then the y-intercept is 3. And remember, the corresponding line y equals 3 is just going to be a horizontal line at 3. Okay, so I'm going to graph that line first. And this is going to be a solid line because we have an equal to here. Now I'm going to graph y is greater than x plus 2. Okay, well, the slope is 1 because there's no coefficient on x, so that's just going to be 1. And then my y-intercept is 2. And notice this is going to be a dashed line. Okay, so I'm going to draw actually a full line, and then I'll erase part of it to make it dashed afterwards. Okay, so my y-intercept is 2 right here, right there. I'll do this in red. My slope is 1. So I'll go up 1, right 1. And I'll go down 1, left 1. Now I'm going to draw my dashed line through that. So now I want to figure out which section of this, these intersecting planes that I want to fill in. Okay. Well, I need my solution set to be less than or equal to 3. So here's my 3 line. I need it to be below this line. Okay. So that's below the black line right here. Okay. So that's going to be down here. And I also need it to be above this line, above our red line right here. This is our red line. I need it to be above. And remember, when I say above, I mean vertical. So if I pick any point on this line, I need to go up like this. Okay, so the only section that fits that's both below this horizontal line and above this red line is this section. If you can see, the intersecting lines create 4 different sections, like 1, 2, 3, and 4. And this one is going to be the only one that works. So this is the section I'm going to shade in because this is my solution set. So I've successfully shaded in my solution set, and now we're done with this one. For this example, I'm going to graph the system of linear inequalities. 2x plus y is less than -1, and then 2x plus y is greater than 3. So what I'm going to do is convert both of these into slope-intercept form. So for the first one, I have 2x plus y is less than -1. I'm going to subtract 2x on both sides. I get y is less than -2x minus 1. Okay, so I'm going to graph that now. My slope is -2. My y-intercept is -1. And this is going to be a dashed line because I do not have an equal to sign right here. So I'm going to plot this. Then I'm going to go up to left one, or down to and right one. Now I'm going to draw my line through this. And I'm going to make it dashed. Now I'm going to graph my other line, but first I'm going to convert this one into slope-intercept form as well. So I'm going to scroll down a bit. I have 2x plus y is greater than 3. So I'm going to subtract 2x on both sides. So I have y is greater than -2x plus 3, because it's positive 3. So my y-intercept right here is 3, and my slope is -2. Didn't mean to draw that there. Anyway, I'll graph this one in red as well. So I'm going to plot 3 on my graph, and zoom in a bit on the graph, and then my slope is -2. So I'm going to go down to right one, and then up to left one. And right now you can already tell that these lines are going to be parallel. And hold on, let me just double check. I do not have an equal to sign here, so I'm going to draw another dashed line. Now I want to figure out what section I want to shade in. Okay, so if we look at our final inequalities here, I'm going to box them right now. Okay, I want to be below this black line right here. This one's the black line. I want to be below this, and I want to be above this at the same time. Okay, well, if you look at that, that's actually impossible. I can't have a solution that is both below this black line and above this red line at the same time. Because if you look, if I shade below this line right here, the black line, that would be right there. And then if I shade above the red line, that would be like this. Because remember, above, I mean take any point and then go directly vertically above. Okay, and this section that's shaded and this section that's shaded is never going to overlap. So that means that this is the no solution case. There is no solution to the system of linear inequalities. So now that we've identified that this is the no solution case, we're done. For this example, we're going to write a system of linear equations represented by the graph. All right, so first thing we're going to do is we're going to figure out the slope and the y-intercept of each of these lines. Okay. Well, I'm going to start with this dashed line right here, and the dashed line does tell me something, and we'll talk about that in a moment. But anyway, the y-intercept is 0. If you can see, this line would cross at 0. Okay. And then my slope is just 1. I'm going up 1, right 1, up 1, right 1. So my slope's positive 1. So my equation would be y equals x. Right. This is just going to be y equals x, but I want an inequality, so I'm going to erase the equal sign here. And now I want to figure out what this inequality is. Okay. Well, I know I have a dashed line, so it's not going to be equal to. It's either going to be y is greater than x or y is less than x. If you look here, the shaded region is directly below the dashed line. So since it's below, this is going to be y is less than x. Okay, so that's my first equation. Now my second equation, this right here is a horizontal line and it's solid. So I know this is going to be y is either greater than or equal to or less than or equal to. And since it's a horizontal line, it's going to be a constant, and this constant value is -2. So I know it's going to be y is something with an equal sign to -2. Now I just have to figure out if this is going to be greater than or less than. Well, the shaded part is above this line. So this is actually going to be greater than or equal to -2, because I know that this is above here, and the solid line is why we have equals once again. Anyway, we've successfully written our system of linear inequalities that are represented by this graph, so now we're done with this one. For this example, we're going to be writing a system of linear inequalities represented by the graph. Okay. Well, once again, I want to figure out the equations of each of these lines, and I can figure out what inequality symbol I want to use. So first I'll start with the dashed line. I see that my y-intercept is going to be -1 because that's where this line is crossing the y-axis. And I see my slope, if you look at it, I'm going up 2 units and then right 3 units. Okay, so up 2, right 3. So that's positive 2/3. So my y-intercept's -1, my slope's positive 2/3. So I know that my equation would be y equals 2/3 x minus 1. But I want to figure out my inequality sign. I have a dashed line right here. So since I have a dashed line, it's not going to be equal. Okay, it's just going to be either greater than or less than. And if you see, the shaded region is above, vertically above the line. So this is going to be y is greater than, because that shaded region is above the line. So y is greater than 2/3 x minus 1. Now, for this vertical line, this one's going to be a little bit trickier, but it will make sense once we go over it. Okay, so this vertical line, if you remember, the equation of a vertical line is x equals a constant. Okay, so this is at x equals 3. So this vertical line would just be x equals 3. But remember, we don't want an equation, we want an inequality. So I'm going to erase this equal sign. And now notice that we have a solid line here. Okay, so this solid means that I am going to have it equal to. So it's going to be either x is greater than or equal to 3 or x is less than or equal to 3. So I'm going to put the line underneath my inequality in anticipation. So here is the equal to part. Now I have to figure out, is this going to be x is greater than or x is less than? Now, whenever we have y alone, I always say to look above or below, because that's the y direction. The y direction goes up and down. But since we have x alone right here, we do not want to do up and down, because that doesn't help us. If I go up here, that's still in the line. If I go down here, that's still in the line. Because the x direction is horizontal, I want to either check right or left. If the shading is to the right, well, if you see, the x values are increasing to the right and decreasing to the left. So if it's shaded to the right, that means it's going to be greater than. And if it's shaded to the left, that means it's going to be less than. So since this is shaded to the left, this is going to be x is less than or equal to 3. Anyway, now we've successfully written the system of linear inequalities for this graph, and now we're done with this one. For this example, you have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents this situation. How much time can you spend at each location? So I'm going to zoom in here. So first thing I want to do is identify my variables. I'm going to call x the hours at the mall and y the hours at the beach. Now you could have had anything for your variables, but since we're graphing and this is what the axes are telling us, that's what I'm going to have. Anyway, I know I have to spend at most 8 hours in total. Okay, so that means that the x, hours at the mall, plus the hours at the beach, y, that's going to have to be at most 8. Okay, so it's going to have to be 8 or less. So I can rewrite that as x plus y is less than or equal to 8, because 8's the absolute maximum that I can have. I could do less if I wanted to, but I only have 8 hours to spend at either of these places total. Now I want to look back up at the word problem. And it says we want to spend at least 2 hours at the mall and more than 4 hours at the beach. Okay? Well, if I look at the mall, that means I want my hours at the mall, x, I'll write that below here, to be greater than or equal to 2. Okay? So x is greater than or equal to 2 means that I want to spend at least 2 hours at the mall. Okay? I also want to spend more than 4 hours at the beach. Well, the beach is y, so I want my y value to be y is greater than 4, because it's more than. It's not at least 4, it's more than 4. Okay? So now I have a system of 3 linear inequalities. That's totally fine. We're going to graph all of these and then figure out where it's true for all of them. Okay? So the only thing that I have to rewrite in slope-intercept form is this inequality. The rest of them I can just graph right away. So I'll graph these two first, and then we will solve and graph this one. So y is greater than 4. This is going to be a dashed line. And remember, y is equal to 4 is going to be a horizontal line at 4. So I can draw a dashed line at 4, so I'll do that right here. I actually decided to do a ray because it doesn't make sense to spend negative hours at the mall. That's why we're only in quadrant 1 here. Now I'm going to make it dashed. Now I'm going to graph the line x is greater than or equal to 2. Remember, x equals 2 is a vertical line at the x value of 2. So I'm just going to do that here, and it's going to be solid because of this equal to. So if you can tell, I graphed that with my green ray right here. Once again, we don't want to have negative hours at the beach. That doesn't really make sense either. Okay, so now I just want to solve this last one for slope-intercept form, and then I'll graph that. So I'm going to move over here. I have x plus y is less than or equal to 8. I'm going to subtract x on both sides. I get y is less than or equal to negative x plus 8. Okay, well, here I see my slope is negative 1, and my y-intercept is 8. So I'm going to plot 8. And then my slope was negative 1, so I'm going to go down 1, right 1, and keep doing that. And this is going to be a line segment. And this line is going to be solid because of the equals underneath the inequality sign right here. Okay. Now we need to figure out what region we're going to shade in. Okay. So x is greater than or equal to 2. That means I'm going to shade to the right of this green line. Okay. So everything to the right there. And then y is greater than 4. That means I'm going to shade above this dashed black line. And then over here we have y is less than or equal to negative x plus 8. So that's our red line right here. And that means I'm going to shade below that because it's y is less than. That means the vertical value is less than. So the only part that I have to shade in is this little part right here. So I'm going to shade that in right now. So I'm going to zoom back out here. So the last question asks, how much time can we spend at each location? Any time that is within this section of the graph right here. So for instance, we could spend 3 hours at the mall and 5 hours at the beach. I could spend 2.5 hours at the mall and 4.5 hours at the beach. So any ordered pair in this little region here will count as a solution to our system of inequalities. And now we're done.